Hi, everybody. This is Joanne, and welcome to an evening broadcast of Read Science. Tonight is a very special episode because we're going to actually do some science on screen, streaming to you live, straight from Liz Heinecke's kitchen. Liz, I have your bio here. Liz has a Master's of Science in Bacteriology and an undergraduate degree in art. After doing medical research for 10 years, she stays at home with her 3 kids, culturing more germs than ever, and I know, I fully know that. Not your house personally, Liz, although I visited. Anyway, so she runs a website called Kitchen Pantry Scientist, and she says science can be as easy as baking and encourages parents to open their kitchen cabinets, stir up some science with their kids, and feed those hungry minds. Her first book, Kitchen Science Labs from Kids, is out as part of their Hands-On Family series. And it's a great little book. It contains 52 family-friendly experiments from around the house that you can do at home with things you have sitting around. This goes, it's not exactly a companion, and we can get to that, but you also have a Kids Science app for the phone, and we can talk about that too. That's one of those apps that I'm always telling groups of moms, if you got little kids, you need to get this app. So you also are on TV in Minnesota with KARE 11 Sunrise News doing science experiments for the general public. So Liz, why don't you say hi to our audience, and we'll let Jeff will throw out the first questions. Let's see.
Okay. Hi, it's nice to see everyone. I'm excited to be here. I'm a big fan of Joanne's from way back, so.
Well, it's mutual, right?
Liz, it's great fun to be talking to you there in your kitchen. It looks like there's so much potential. And I was listening to Joanne talk about your science and art degrees, and I just changed my mind about what my first question would be. We'll get to it later, but I was positively struck first in Lab 2 called Build a Volcano.
Oh,
and
yeah.
then some other ones later, where in step 2 of Build a Volcano, you give this as part of the instruction: decorate your volcano. Now, you have other experiments, many of them, in which you suggest painting eggs with eyes, decorating things that are about to be blown up, such things. So as a rhetorical question, because Joanna and I know what we think about art and sciences, let me ask you how you see the importance of making these decorations as a whole part of doing this science exploration.
Oh, well, I think, all kids learn differently, and I've always loved art and music, and I'm a very visual person, so this helps me learn. And I think that when you're teaching kids, you want to get them excited about the subject in any way you can, and I think adding creative aspects to science projects makes them better projects, really. So if a kid has to think about what a volcano looks like, it's fun for them to draw on the volcano.
Do you think this gives them an extra view on how science itself is a creative activity, maybe?
Oh, absolutely. I think I worked in labs for 10 years, and the best scientists the graduate students that I saw coming through the labs were not the students with the highest SAT scores. They were the students who had good ideas. And I think when you mix the arts and the sciences, I think it teaches you to be creative, and I think creativity is essential to science.
Okay, now I'll ask my first question, since we're talking about all these things that enhance our interest. In your introduction to the whole book, you said kids discover that science isn't hard and that they can find it everywhere they look, which I think is a great attitude and things, and maybe can encourage parents too. But this is an essay question. Tell us about that. Let's talk about kids not finding science hard when they're young enough, where they might get that from, about finding science wherever they look, even in your kitchen.
Right. So kids are born curious, right? We're all born curious, and one of the greatest gifts we can give our children is to nurture this curiosity. So from the time they're 2, you don't have to wait until they're in school to start doing science with them. From the time they're 2, when you're going on a walk and they stop to look at a bug, I mean, that's a teaching moment. They ask you a question about the bug. You might not know the answer, but you say, I don't know, why do you think that bug's crawling faster than all the other bugs? I think when you're in the kitchen cooking with your kids, it's great to know a little bit about the science of what makes cookies rise. So baking soda, it's a chemical reaction that makes cookies rise. And I think if parents start doing some of these experiments in the kitchen with their kids, the parents are also learning a little bit about science, and you learn that your kitchen is actually full of chemicals. You're doing chemical reactions all the time. Chemicals aren't scary. Science isn't scary. You know, you can talk about eggs. Why are eggs strong enough that I think I have in my book that if you hold one in your hand with no rings on and squeeze it as hard as you can't break it because of the architecture of the egg. And yet chicks, they're fragile enough that chicks can peck their way out. I mean, that's amazing stuff. It makes you think.
And then that makes me think, we're thinking about parents who, you know, the kid may see the worm, and it would be nice if the parents would engage that teachable moment. But what do we tell parents who feel too intimidated by science or worry that they won't know the answer?
I would say
that it's not that important, really.
Yes, I would say you don't have to be a scientist to love science, and you don't have to be a scientist to do science with your kids. There are so many safe, easy, approachable experiments you can do. Even if you play 20 questions with your kids, you're teaching them a way to think about the world and ask questions about things. So you don't have to be a scientist to do science. You don't have to be Julia Child to make some great food in your kitchen. It's approachable. We as science educators have to make people realize it's not hard, it's not scary, it's approachable. You can do it.
I agree. I think that, well, and I've got 4 kids, and if people who've tuned into my show, our show, Jeff, look at me being selfish, tuned into our show, know that my 2 oldest have chosen science careers. Now, I'm not going to take all the credit for that because their high school physics teacher was amazing, and they both chose physical sciences. But I know some of it is just saying, you know, if you as a parent walk around with sort of a, you know, if you speak out loud and you say, well, I wonder why my laptop's getting hot, I wonder why that is. You know, no matter what it is, if you make an observation, be aware enough to sort of turn it into a question, like, I wonder why that is, because then your kids pick up on that day after day, right? But I think where you come in, and you're very helpful having a book and an app and a website, is that we look at science and think, well, let's say we do want to do something structured. Oh, that's so hard because we have to get all these supplies and we have to think about it and we have to set it up and we have to do all these things. But I think your book, and especially your app, shows that it doesn't have to be that way. It doesn't have to be that difficult. And I have to say, and Jeff would probably agree with me, I really like the style of your book because it feels very homey, you know, very home-like, very, you know, I guess maybe down home's the way to talk about it. It just seems really accessible and friendly. It's not just, even though I love Dorling Kindersley type books that are very colorful and the font's very clean, I like this because it feels, you know, like just friendly. And you have a lot of pictures showing step-by-step real kids doing the experiments.
It's all my kids and my friends' kids. Yeah, it's all shot in neighborhood kitchens and neighborhood streets. It's just what it looks like. It's kids doing science.
So reveal the secret. Are those pictures of kids being astounded by the results of an experiment spontaneous, or were some of them staged?
Most of them are spontaneous, although I think that my 12-year-old and her friends might have exaggerated their expressions a bit. On a few of the experiments they had seen before. Probably the first time they were in shock and awe, but after they've seen it 5 times, I think there was a little acting going on.
Well, you have a great photographer.
Oh, Amber Procaccini. She's amazing, yeah.
So why don't we, since I keep mentioning your app, and it's going to be a little hard to show. I should have pulled it up already. But, okay, so you guys, this is such a fun app. Let me just, I don't know if the color's going to be true on here. Kids Science Premium, and it pops up. And this app is fantastic, telling me something. They're going to add more experiments. So this app is always updated, right?
Yes, we try to add more experiments every so often. Usually, especially around Halloween and times of year, you want some great new science experiments.
So I'm looking here at a featured experiment called alum crystal geodes.
Oh, yeah.
And you would just click on that, and it gives you a summary of what the experiment is, an age, suggested age range, and then duration. So that's really important if you're a busy mom. Is this going to take me 15 minutes, or is it going to take me an hour? Or does it have to sit overnight? That's so important. So, and then along the top, it's interesting because you've got different things. I can't read them, they're backwards. Overview, the recipe, tells you exactly what you need. The images of kids doing that, so this probably helped you with your book.
Yeah.
And then in the premium, you have videos with some of them where a parent could watch them go step by step, or a kid could do the step by step.
Hopefully the kids watch them and then they just do it themselves.
So,
sorry, go ahead.
Oh no, what I like, I'm trying to find out where it is here. So you have it so that this is set up. I love this, you guys. Everybody gets so excited about this. Find an experiment, and you can find an experiment. Just, you know, does the name of the experiment intrigue you? What is in your pantry? So if you go there and you say, well, you know, it's just a really long list, and you could tick off the things you know you have, and by that list, you know what experiments you can get to and do with the kid. The other is age group. So, you know, are you going to do this with 3-year-olds, 6-year-olds? Type of science. So I guess that's physics, chemistry, biology. And then amount of time. So really, whatever your limitation is, you can use this app. And so I just love it. I mean, because I just remember those days when I just had kids running around, you know, and if time was the most important thing, that's what I would have chosen. If I went, I don't want to have to go, if I have to go to the store and buy something, it might not happen, right, Liz?
That's really why I started doing this, because I wanted to do science with my kids, but I did not want to go to the store. And, it's torture to go to the store with 3 little children.
Yeah. Oh, yes. I remember that. So, like here, I just clicked on like age group, and I clicked ages 3+, and then these are the experiments that have popped up. Lots.
Yeah.
So,
since you mentioned science types, Joanne, one thing I wanted to do was to look. The book is divided into labs or experiments that are grouped into units. And I wanted to read a few of those, starting with Unit 1, Carbonated Chemical Reactions, Crystal Creations, Physics in Motion, Life Science, Astonishing Liquids, Polymers, Colloids, and Misbehaving Materials, Acids and Bases, and more things, including my favorite, Rocket Science. Yeah, because I've done that. And my only comment here is that there is a lot of variety. I was very favorably impressed by the amount of variety in the different types of science that you look at. I guess that's an essay question. There's a lot of variety. It's like, where does that all come from? And it shows up in the app. There's all sorts of things to suit everyone's taste, it seems like.
Well, I'm a biologist, so, you know, my personal favorites are the microbiology experiments, you know, culturing microbes from around your house, and I love the experiment where you extract DNA from strawberries.
Yes!
I used to work in research. I was a molecular biology researcher, so I love that.
Yeah, and I'm a physical scientist, so I'm reading the things for how to extract DNA from a strawberry, and I'm thinking, for kids? It's like, isn't that, I was astounded, and there it is, and you can do it, and I thought, that's really cool. I want to go get the DNA out of a strawberry.
It's so easy, and I'm very fortunate because my dad is a physicist. So
Mm. That is fortunate indeed, yes.
But he gives me lots of great ideas, and he, you know, I would say, and this is a great thing for parents too, you can't know everything about everything.
Mm-hmm.
So for me, it's been really educational to do these experiments, and I'll think, I don't remember why that happens, and so I look it up, I talk to my dad about it. It's been a great way to help me see the world differently too, and to remember some of the science I've learned, and I think a lot of adults would be surprised at how much they actually remember if they think about it a little.
That's right. Well, I'm just listening to Jeff here and thinking, we're doing this all wrong. We're going to have Liz do the demos. We should have had Jeff set up some demos and see and watch him follow the directions.
see if even I could extract DNA from a strawberry.
Well, that's it, you know, and then you could challenge me and Liz, the non-physicists.
Yeah.
But see, Liz, you have physicist parents. I have physicist children.
Yeah, that's funny.
Yeah, we're everywhere.
They're everywhere.
Yeah, Jeff, you have to try the water rockets. Those are really fun.
Oh yeah, but you know, I figure I know how those go, so I'm more like I want to culture things from my countertop in the, you know, the agar solutions on the plates, and I want to make. I used to do fluid dynamics too, so I want to make shapes and break the surface tension and watch things flow. And I wondered why you didn't have an experiment of dropping milk into a glass of water. That's a very pretty example of chaotic motion and turbulence.
Yes,
anyway.
I will have to do that in my next book.
Well, I was going to say, it was just one book, right? You can keep going on and on. And so, of course, your book is well laid out with the materials, safety first, always, and then your protocol and your science behind the fun. So parents aren't left, you know, they can read the script if they want, or if the kids are old enough, they can read it to you. So looking at this, what was the most challenging thing about creating a book like this?
I think it was making sure that I had experiments that I knew would be fun for the kids. Sorry, the sun is in my eyes. But also experiments that worked well, that my kids and I had tried several times and had worked consistently, because I didn't want to put experiments in there that didn't work well. So these are all tested, like I said, several times by the kids and me, and we redid them when we shot the photos for the book. We were actually doing all of the experiments. Every single page, we were doing that experiment.
And I thought unexpectedly sophisticated, too, rather than sort of the popular gee whiz type experiment that doesn't really have much going on. Standing on eggs successfully has a lot going on that you can talk about, but it's fun, too, because like, wow, I'm standing on eggs.
Yeah, and sometimes they break.
Yeah, but you know, and
I've done that on TV.
I marked that out, that in that experiment, you wrote the caption in Figure 3, and I really appreciate this. You said the eggs probably won't break, and I think that is so cool because, you know, science doesn't always, experiments don't always go the way we expect them to, and occasionally things happen.
Yeah, and I believe in the introduction of the book, or at some point, I write about that. I say, some of these won't work the first time you do them. You may have to adjust things and try again. You'll make mistakes. That's what science is. It's making mistakes and then asking the question, well, what could I do to make it work? And great discoveries have been made from mistakes. I think one important lesson to teach kids is that it's okay to make mistakes, and at home is a great place to not be afraid to make mistakes. So that's one thing that's so wonderful about doing science at home. No one's grading you. No one's judging you.
If Joanne will indulge me one more remark while we're on the topic of not treating science as too pristine and putting it on too high a pedestal, but being more familiar with it. Early in the book, you talked about hypotheses, and you said a hypothesis is a guess about what might happen based on what you already know. And I think that's a fabulous remark that is so accurate. It captures almost everything. And at the same time, I thought about the number of nervous science defenders who might be upset because you use the word guess. And I think, but it's true, and it does happen, and that is what we do. And so, you know, that's a way of commending you for what? A casual approach, a friendly approach to the science, a demystifying approach to say, like you reiterate, that science is something for people to enjoy and learn from, not to be afraid of.
And that's how you learn to love science.
Yeah.
And that's what ultimately science communicators, I would hope, would want, is for the public to learn to love science, because it's important to science, it's important to the well-being of the planet, everything about it is important. So.
And I think, you know, it just helps you relate to the rest of the world, and, you know, experiments like this especially help you relate to the world because you're using your stuff that's in your kitchen, in your house. Did you have any experiments, maybe not, yeah, I doubt they would have made it in the book, but like that were just really frustrating, like you're like, okay, this one is not going in the book?
Oh, I have a couple that I did not put in the book that I wanted to. One of them was when you stack up coins, pennies and nickels, and you put you make a battery basically.
Yes.
Yeah.
With salt water and the paper towels.
Yeah. It never worked.
I know.
A few times we felt a little buzz. I could not get that to work consistently, and I threw in the towel and put in a different experiment because, you know.
Yeah, no, that one is notoriously difficult to get to work, and I'm sure someone will pop up and tell us, you know, oh, no, this is what you're doing it wrong. But I've not been able to get it to work because I've wanted to put it in a video myself. I just not had good luck with it. So what's your other one that you, if you can remember?
One thing that I've really wanted to do is to do a non-dangerous demonstration of electrophoresis, how it works, how scientists would run DNA in a lab. And so I thought maybe I could do it magnetically with the little iron particles from cereal. I saw that online. You can actually get iron particles from breakfast cereal using a strong magnet.
Right.
But I have not been able to get the agar concentration or gelatin concentration right to get them to move through. That's one I'm still working on. Someday I'm going to get it to work.
Yeah, well, I've seen that work, some playing around in the lab, like someone took Raisin Bran and was able to get that. But yeah, it's not short.
No, it's easy to get the iron out of the cereal, but then to magnetophoresis, I guess, it through a gel is tricky. But it would be cool if it worked.
Well, yeah, well, that could be the makings of a more sophisticated book.
Yeah.
But experiments, yeah, go ahead and give them a try, but don't hold your breath or something, right?
Okay.
Be a real scientist.
I have a short actual question I want to know that has to do with expectations and how kids learn and their misperceptions sometimes that are interesting about how physics works. But the experiment when you were describing the egg throw experiment, where one throws a raw egg into a bed sheet and it doesn't break. Are kids surprised that it doesn't break?
They are. I think kids think if they throw anything hard enough, they can break it. Kids think they have superpowers, I think. But they are surprised, and they love. I mean, it's a great physical learning thing, right? Some kids love sports. So this is a great way for kids to love sports, who love sports, learn physics doing this.
Yeah.
And then the fun thing then is you, of course, throw an egg at something that doesn't stop it so slowly, and it smashes.
And the pictures would suggest that the boys love smashing the eggs there, and the girls were more attuned to throwing the eggs into something that didn't break them. Something. It seemed like I kept seeing pictures of boys by the really brutal blowing up things.
Oh, that's funny. I tried not to do that. In fact, in the egg throwing picture, I specifically chose a picture where the girl was throwing the egg.
Yes.
Yes. And I think there's a picture of a girl and a boy having a water balloon fight together. Oh, right. And girls are shooting the water rockets, I know.
Yeah, and I shouldn't say I kept seeing, okay, I saw one where boys are blowing up something, and I thought, this looks like a real boy activity here. But yeah, it's nice to know that girls can enjoy throwing eggs and standing on eggs and blowing things up, and that the boys were enjoying culturing things that they found, I don't know, on their counters and in their mouths and in their fingerprints.
The boys doing the microbiology experiment, their mom is a fantastic baker, actually. She has several cookbooks, and her youngest son is quite a baker himself and does lots of videos and things. So the kitchen was a great place for him to be.
Oh, and I need a bit of practical advice, just because the other day we were talking about the correct way to make Southern sweet tea, which requires, of course, making a supersaturated solution of sugar. And so I want to know, can I use Southern sweet tea to grow a geode?
Oh, I don't know whether the alcohol would interfere with it. That's a good question. I would try it.
Yeah. It's just sugar and tea. There's no alcohol in this. This is
there's
just
no alcohol.
Southern style sweet tea.
You just make sure that you have something to seed the crystals of. So you need a crystal in there to start the growth. But that would be fun.
It would.
I like experiments that you can eat when they're done. That's a good one.
Good. Well, and Jeff, you'll have to get put on a Southern accent to really enjoy your sweet tea, your sweet tea.
I'll work on that. Thank you.
You're closer to the South than either Liz or I. So
we're below the Mason-Dixon line here, so yes.
That's right. We have a question from the audience, and that's right. You guys can submit questions for Liz. And this one says, were you ever worried that your kids wouldn't be as interested in science as you were when you started?
That is an excellent question by Amber, my book photographer.
Yay!
I was never worried. And it's been my experience, some kids love science more than others, like some kids love music more than others. But I have yet to find a child, and I go around to lots of scout meetings and schools, I have yet to find a kid who is not excited to do a science experiment. And obviously I try to pick experiments that are entertaining, you know, inflating a balloon with carbon dioxide gas when I'm going out to do science outreach. But no, I think that most kids can get engaged at some level and get excited about science. So I was never worried.
And speaking of engagement, this is another quickie. You know, the book is all about engaging kids in interesting but non-superficial ways, let's say, with science. What does it take to engage the parents? Do they come along? I think I enjoyed the book a lot, and I found many things that even made me think, as I had to think through some things, and I wouldn't say question, but wonder about some of the things and how they would go. Are parents engaged by this book? Do you have to do something special, or if it's just an interesting experiment, do they come along for the ride?
I hope they are engaged by the book. It's been my experience as a parent that your kids force you to engage in things. They'll demand that, you know, I want to make this recipe or I want to do this experiment until you do it. And then they'll say, well, why is this? So then maybe the parent has to look at the book. And this happens to me all. I know nothing about robotics, but I've been going, and it's cool. I kind of love it. So I would say parents are often forced into things, but then they end up being more engaged than they expected.
Yes, I was going to say I learned so much about construction equipment from one of my kids who just was like fascinated by it, or geography, and so your horizons expand as a parent once you have other people with their own interests. So I'm looking at, it's the bottom of the hour, and we want to leave time for some really cool demonstrations, and people in the audience, if you have questions about what she's doing or anything else, feel free. I'm sure we are going to be able to interrupt her and keep carrying on a conversation while she does demo a few things for us.
I'm going to call my oldest daughter. Sarah, is May over there? Yeah. May, come on over. My daughters actually argued about which experiments they would get to do.
I see.
They have their favorite. So we've come to an agreement. That's okay. Come on. Yeah, it's fine. This is May.
Hi, May.
She's all getting ready to go to basketball practice. Yeah. May is going to assist me with an experiment involving polymers. And May, remember this? What's this experiment called?
Green slime.
Green slime.
Mm-hmm.
So all you need for this experiment is glue, a little green food coloring. There's our dog. And water. You mix equal parts of glue and water, right?
Yeah.
Put a little green food coloring in. And then the magic ingredient, so polymers are just long chains of molecules. You can explain this to kids, kind of like beads on a necklace.
Mm-hmm.
And in glue, the polymers are all kind of sliding around next to each other, these molecules. But we can add something called a cross-linker. And in this case, it's borax laundry detergent. That's probably backwards. You mix together a couple spoonfuls of borax in maybe half a cup of water. And I'm going to have May do this. When you're actually doing science with your kids, they should be doing everything. May's going to pour some borax. We're going to hold this up into, can you pour it into the glue? All right, that's probably good. You don't have to pour it off. Okay, that's okay. And then she is going to stir it together, and we're going to see what happens. Now, when you add the cross-linker to all these long, slippery molecules, it makes them stick together, kind of like spaghetti sticks together if you let it stick in the colander. Okay. So May is going to reach into the bowl and show you what we've created. Let's hold it up close to the camera. Okay, you're going to pick it up. Ooh, green slime. And seriously, what kid would not like playing with that? You can roll it into long snakes. It's very rubbery. It's a polymer, so you can kind of make it into a ball. Okay, so that's our first demo.
That's really cool.
About our polymer slime.
Well, no question about the polymer slime. There was a question and it disappeared quickly, but if I recall, it was about, you know, kids when they're young, they're naturally curious, but then as we get to be adults, there's less interest in science. So what, do you have any suggestions about how we can keep that interest going?
I think you just have to keep your eyes open. Keep reading, keep looking around you. Try to remember what it was like when you were a kid. I think having kids really helps you see the world like a child again. But yeah, just try to remember what it was like to be 9 and look around.
In another one of the labs, we got to make glue from milk, which I thought was really cool and taught me why it is that you can make glue out of milk, and you're using Elmer's glue here. Could you mention that protein and explain that?
I believe it's casein protein that's in the milk, and when you add an acid to the milk, it allows this protein to be separated out from the whey, I guess it's called, of the milk. And you can actually use this. It's a polymer, so it's like glue. It's long chains of molecules, and you can actually use it to make glue, or you can. There's another protocol where you can kind of make it into a plastic that's a little thicker. And you can mold it into little shapes or beads and dry it. So. Or
you can make cheese.
Yes, that's. In fact, I wanted to do more food science. That's how they make. What is the Indian cheese called? You just add lemon juice to milk to make it.
Oh, I don't know.
I can't remember. Anyway, yes, you can make cheese just by adding acid to milk. So cheese, I guess, is also a polymer. Okay.
So she's having fun with that.
Yeah, see? It's fun. It's fun to play with. Lots of these things are. Okay, now we are going to do, you're next, Sarah, just a second. Next, we're going to do an atmospheric pressure experiment.
Oh.
And this is a very classic experiment. I was at a meeting a couple weeks ago, and there was an educator there who described it, I thought, in a great way. He said it's sort of like we're sitting at the bottom of a giant swimming pool full of air. So there's all this atmosphere above us, all these air molecules are weighing down on us, and that is exerting pressure on us. And we don't notice it. But you can use this pressure to push an egg into a bottle. Now, May, hold this egg. Will this egg fit into the bottle if you just put it on top?
Is that a peeled egg?
Yeah, it's a peeled hard-boiled egg. It won't go in the bottle. But, and we have a cute little egg cup here. If you stick some candles in the egg and light the candles, there is a chemical reaction that happens called combustion, right? So we are going to use this reaction to heat up the air inside this bottle and it will deplete the oxygen and the candles will go out. Then, and it also forces some of the gas out of the bottle. As the bottle cools rapidly, go ahead and light them, May. As the bottle cools rapidly, the pressure drops inside the bottle, and there's a little bit of a vacuum that forms inside the bottle, and atmospheric pressure will push the egg into the bottle. Now, this is a really fun one, so I'm going to try to hold it up so you guys can see it. Right, May, do you want to hold it? Sure. Okay, so why don't you, I'm going to hold the bottle here. Why don't, May is just going to put the egg, oh, that's okay. I blew one of them out. We'll see if it still works. The egg right here, so the egg is just sitting in the egg cup. Okay. The air is heating inside the bottle. Do you hear that? Atmospheric pressure pushed the egg up into the bottle, which is a kind of cool experiment.
I like
the
how
most
it's
satisfying sound, too.
Yeah.
I love the pop.
Now,
Right.
how do you get the egg back out of the bottle, huh?
You have to break it. Although, I saw Bill Nye demonstrate doing this with a water balloon. And if you have a water balloon, you can actually just put a toothpick or something up next to it, which allows air back into the bottle, and then you can hold a water balloon.
Ah.
Okay, all right.
All right. My
Thank
youngest
you,
daughter's
May.
Thank you, May.
coming now. I'm going to scoot over. This is Sarah. Sarah, can you wave at the camera?
Hi, Sarah.
Sarah's 8, and she is also
Nice to meet
she
you.
started doing science experiments with us when she was about 2. And lots of times the older kids would be actively doing the experiments, and she would just be, you know, playing with, dumping things out or playing with them. But it's great. She's exploring the world, right? She's learning what the shape of an egg is and how a hard-boiled egg feels. So I tried to make the experiment safe enough for younger kids, too. Okay, so first we're going to do an experiment, another polymer experiment that's fun for Halloween. Plastic is a polymer, like I said before, and it's very good at making seals around things. So we just have a plastic Ziploc bag full of water, and we put some red food coloring in it. So what do we call it when there's red food coloring in it? Do you remember? For Halloween? We call it a bag of blood.
Yeah.
Now Sarah's going to take some barbecue skewers. So most people probably have this in their house. And she is going to poke them. Try not to poke your hand. Yeah. Through the bag. And amazingly, let's hold it up. Let me hold it up over my computer keyboard. The bag does not leak. And this is simply because polymers are so good at forming seals around things that you kids can poke a whole bunch of these sticks through the bag before it starts to leak. Eventually, it'll leak. You can also talk about surface tension a little. The surface tension of water around the edges of the skewers helps hold it in the bag too. And I have a couple surface tension experiments in the book. All right.
Now, in the book, why did you caution us not to poke through the airspace?
If you poke through the airspace up here, it allows air to escape out of here. It changes the pressure inside the bag, and then that can push the water out through the holes. All right, so I'm going to give Sarah, or I'm going to give this bag to May to empty over the sink, but isn't that fun?
Yeah.
Yeah.
For a Halloween party trick. All right. The final experiment we're going to do you have any questions about that one?
No, nothing's come through. I think it's pretty fun. So, yeah, don't do that with a paper bag.
No, it will not. Because paper bags are porous. Okay. This is my favorite.
pH.
Yep.
I know it's going to be pH because it's the
pH.
cabbage.
Okay, this is my favorite science experiment ingredient in the whole world. It's red cabbage. So you can buy it at the grocery store. And it contains a pigment that is an acid-base indicator. So you can tell kids that it changes color depending on whether you put it in an acid or a base. And it does this because pigments are molecules, and this particular molecule changes shape depending on what it's in. So if you put it in an acid, it changes shape and absorbs a certain wavelength of light and is one color. But if you put it in a base, it changes conformation or shape, and it absorbs different wavelengths of light, so it looks a different color. So when you put it in an acid, it looks pink, and when you put it in a base, it looks blue-green. So if you chop this up and boil it and take the juice out, you get this purple color. And at a neutral pH of around 7, this cabbage juice is purple. Now, if you make this, the first thing you should do is soak some coffee filters in it and let them dry, because it lets you make homemade litmus paper.
Oh,
so
nice.
Let it dry. You cut it into little strips. Now, Sarah's going to demonstrate this. This is really cool. First, I'm going to have her dip. So you can have kids test whether things are acids or bases. Tell them it turns pink in an acid, blue in a base. Sarah's going to dip this. Okay, you want to move this? Sarah's going to dip this in vinegar first. So go ahead and dip it in vinegar. All right, what color did it turn? I'm going to put it, can you set it on the plate here? So you can see that it turns bright pink.
Yeah. Very
All
pink.
right, now this is just baking soda and water I've mixed together. And I try to tell kids when I'm demonstrating science that vinegar is just acetic acid, and I have them repeat it. The more you can get kids saying science words, chemical names, the more comfortable they get with them. This is baking soda, which is sodium bicarbonate. So Sarah's going to dip this next piece of litmus paper in sodium bicarbonate, or baking soda, and see, it turns bright blue. Isn't that cool?
Yeah, very different.
And you can actually dry these. This is an art option. You can dry them. They turn more green than blue, but and kids can make collages out of them. It's actually a really pretty science experiment. Okay. I'm going to quickly show you another. This is, if you're talking about environmental science, you can use cabbage juice to do this.
Wait, I'm not using these cups.
We're going to do that next, Sarah. I didn't tell her we were going to do this one. I'm going to have Sarah, this is just the cabbage juice, pour some carbonated water into, just fill it all the way up into this cabbage juice. Okay, that's to the top. That's good. Now I'm going to have her pour some regular tap water into this one. Can you pour this tap water into here? Yeah. Okay. And then she's going to compare the color. I don't know if you guys can see that.
Yeah, there's a slight difference.
Sarah, can you? It's hard to see, but the one that we added the carbonated water to is slightly pinker than the one we added the uncarbonated water to. And you can explain to kids that carbonated water and pop are carbonated with carbon dioxide gas bubbles, and that when you add carbon dioxide gas to water, it makes it slightly acidic. So you can talk to them about ocean acidification, or you can talk about why soda is bad for your teeth. It's a fun little experiment. Okay, now Sarah's been waiting for our grand finale. Right? Is this your favorite experiment? One of them? Yeah. We call this magic potion.
Ah, yes.
Yes, this is another one where we let kids test the pH of different substances.
Do I need to do it twice?
Well, you're going to add, she's going to add several spoonfuls of baking soda to this cup of cabbage juice. And I'll remind her, I'll say, remember that bases, quiet, my dog is whining, sorry. That bases turn this molecule blue. Here. I'll do it. She's letting the dog out.
No.
Okay. Okay. So we add several spoonfuls of baking soda to one of these. Are you okay? Okay, you do it.
Science can be
Now stir it up.
fun. Yeah.
Oh yeah.
Oh look.
And this is a great demo to do with big groups of kids. You just do it in little sample cups. It's a really good one for science outreach. So you can see it's blue, kind of a cloudy. There's so much baking soda in it.
But it's very blue. Yeah.
Very blue. And now she is going to pour
Which one?
vinegar into this one.
Yeah.
Is vinegar an acid? Remember?
Acid.
Acid. Yeah. Okay. You can do it. Help me. Usually I have the kids do it, but we have smaller amounts. Okay. So you can see that turns vivid pink.
Yeah.
Now this is my favorite thing. You ask the kids, does anyone know what a chemical reaction is? And lots of them will say, ooh, it's an explosion or whatever. But you can say, explain to them, all a chemical reaction is when you mix two things together and you make something new. And you explain to them that the new thing that we're making with this reaction, it does look like a tornado, see? The new thing you're making in this reaction is carbon dioxide gas. And you can explain that it's part of our atmosphere. We exhale it when we breathe out. And that you can explain it's invisible, but we can see it because when we're making it, lots of times we see bubbles like you see in a carbonated drink. So you're explaining to them that the new product that we're making in this chemical reaction when we mix together vinegar and baking soda is carbon dioxide gas. So I'm going to hold this up right in front of the camera, and Sarah is going to pour, up to the top, pour the pink one into the blue one.
Ooh.
Keep talking.
Whoa, isn't that cool? It's also
Wow.
because it neutralizes the reaction and it turns purple again. So this is a really fun hands-on experiment for kids. And like I said, if you make a little bit of this purple cabbage juice goes a long way. So
It does get smelly after a few days.
it's stinky. But you know what? It's fun to talk about that with the kids too. You can talk about, because when you get all these bubbles, you can smell the cabbage more. So you can talk about how lots of times chemical reactions they change the temperature of something, they change the color of something. You know the reactions are happening because sometimes there's an odor. So it's great because these experiments are all really sensory. Lots of kids learn by touching. If I inflate a balloon with baking soda, I let the kids all come up and touch the bottle because they can feel that it's cold. So I think kids learn all different ways, and science is a great way for families to explore the world together because you can learn lots of different ways. They're fun. I don't know. I think it's awesome.
You gave me lots of little things that attached to things I wanted to ask. And one is an idea I've had for many years, and you seem to share it, which is that you do this in the book. You use actual science vocabulary to describe what's going on, big words that we don't worry about. And my leading question is, talk for a few minutes, if you will, about the idea, about the value of using actual science words without fear.
I think it's very important for science words to become part of the vernacular. And kids are not afraid to say big words. Whenever I go out and do science outreach, I have the kids repeat acetic acid, sodium bicarbonate. They can do it. My son loves science, and he was drawing little cartoons on the driveway saying, "That's Salmonella enteritidis." They love it. You know, kids love dinosaur names. There's no fear. So it's a great time for them to be learning that these words aren't scary. And I went to
they're long and melodic and fun to say too, and kids like fun things to say, right?
They're musical almost. You're right.
Yeah.
I thought about that. So I think it's important. I think the more kids are exposed to the language, the more they use the language themselves, the less fearful they become of it, and the more ready they are, the more well prepared they are when they start doing science in school.
You also mentioned, and in the beginning of the book, you said you had 3 criteria for including an experiment in the book: that it has to be safe enough for the youngest person,
Yes.
and it must be engaging enough for the oldest person, and ideally it will use ingredients around the house that you have already.
Ideally, yeah.
Tell us again the age range of kids before they get too sophisticated or they're too young. You encompass quite a wide range here of people who are engaged by this, including the parents. We know that.
Yeah.
What's your age range that your kids have been doing this?
So like I said, Sarah started doing this when she was 2. I used to help watch. I did a child swap with one of my friends during the week, and when I had her kids there, we did a Science Wednesdays. We just started doing it. But that's when I started doing this. And I had ages 2 to 6, and I quickly discovered that they all wanted to participate, and they participated at very different levels. But I gave each of them a notebook, which they're just amazing, and let them, even if they couldn't actually do the experiment, they could scribble the colors of the tie-dye milk, in the notebook. And I had them, the older kids, I would have them write the date, and I would have them write, surface tension, or, monarch butterfly, or whatever we were talking about that day. And I found that they could all engage at some level in what we were doing, and they loved it. Well, 2-year-olds didn't want to be left out.
No!
We wanted to get our hands in there.
They bubble and foam and squeak and shoot and explode, and that's fun. And I had one other thing I wanted to commend you for doing in this book, and that is having a whole page and always referring to the idea of keeping the journal and writing about it, because that is such a useful lesson to observe analytically and to talk about what you see and think about it.
Yeah, and working in a lab, I became, intimately familiar with the importance of taking good notes and keeping good keeping good records of your observations. Sarah's bouncing the green slime now. What was it? Okay, you got to stop because I totally forgot what I was going to say about the notebooks. Oh, when I was taking science classes in high school and even in college, I always found the lab write-ups to be pretty intimidating. And it wasn't until I started working in a lab that I realized that I was just recording my observations. That it's essential to write the date, who did the experiment, and labeling. Even now when we do experiments or if I go out to do science, I try to make sure everything's labeled and talk to kids about, you want to make sure it's labeled because you want to know what you're adding to things. You don't want someone, if there is a 2-year-old around, you don't want them eating the laundry detergent. It wouldn't kill them, but it's not ideal. So, yeah, and it's artistic. Kids like to draw, and they can do the notebook the way they want to. In school, they'll start making them do it a certain way, but it's important for them to realize that what I'm observing is important, and if I keep track of it, then I can see if it changed the next day, or I think it's great for kids to do.
There really shouldn't be too many rules, should there?
No, I don't for science notebooks. My only rule was I tried to get them to always write the date.
Yes, put the date. Yeah, it's not like you're going to say only in pen.
No. Or you must write your hypothesis. If they were old enough, I'd say, what do you think is going to happen? Lots of times I write it down for them because it would, kids don't always like to write either. But then I could go back and ask them that. So.
Right, Ellen. Yeah, it's a good one. Is there a favorite experiment you get asked to set up more often than any other?
Probably the magic potion. And people love the green slime. Yes. It's very tactile, so kids love it. And they can take it home. They can put it in a little baggie and take it home. The cornstarch goo is also really popular. It's the sheer thickening. You just mix together cornstarch and water, and that's one that adults really engage in.
The non-Newtonian fluid.
Non-Newtonian fluid. It's hard not to have fun with it. So.
Yeah. You could find it, I'm sure, but there is a remarkable demonstration that the Mythbusters did with a huge tank of cornstarch solution that Adam Savage ran across without sinking into.
Oh, I want to try that.
Yeah, where do you get that much cornstarch, right, on any given day for your typical mom? So. It looks like we're getting to the end of the hour. This has been great fun, and like I said, it's the first time we've ever had demos, and that's been fantastic. So what I want to do is, Liz, to give you an opportunity to add anything else that you want to add. Maybe we forgot to ask, or you thought, oh, for sure I want to mention this, and we forgot to get to it. Do you have anything like that? Parting words for the audience before I plug your app and your book again?
Oh, thank you. No, my parting words are just, do science with your kids. It's not hard, it's not scary, it's not dangerous, and you'll be glad you did. It's a lot of fun. So I always say, just do it. Go for it. Get your hands dirty. Let your kids get their hands dirty.
I agree. I mean, because my house had stuff going all the time. I wasn't always perfectly organized, and believe me, if I had your app when my kids were little, that would have been a lifesaver. Like I said, some things sort of got pushed aside because I wasn't going to go to the store. But so for all of you out there who want to engage your kids, or maybe you want to do some experiments like Jeff's now going to do, I'm going to make him do it for an episode.
Oh, yes. I'm looking. They're so much fun.
So we've got Liz's book called Kitchen Science Lab for Kids, and Jeff, 52 family-friendly experiments from around the house. And also on the phone, you can get yourself the app, the Kids Science app.
Yeah, it's one word. It's one word, Kid Science. Yeah.
Kid Science app. And so is this only iPhone, or do you have an Android version too?
We would like to make an Android version, but we don't have the funding to do that yet. So.
Sure. Well, hopefully. So yeah, because the app is free, but you can get the premium.
Yes.
For extra, and that's got extra videos and extra experiments and things like that. And this is, like I said, it's great fun. My favorite aspect is the what's in your pantry. That's my criteria for choosing experiments when I get any young kids coming around anymore. So. Anything else from Jeff today?
No, I've had so much fun, and this is a fun book. I wanted to let people know that it's got a lot of fun things to do, but it's fun for parents and for kids, and it has a philosophy of being fearless about science because one should not worry about it. And the diversity of science topics that you touched on, I think, is remarkable. There's a little something from almost every scientific discipline, and that was very fun, and it's very sound too. It's you don't just make up things, but there are good, solid answers that go with everything. And I think that's all wonderful. It was great fun, Liz.
Thank you. That's a huge compliment.
So, Liz, thank you so much for joining us, and best of luck with your book and future publications, which I'm sure will do just as well and be as engaging for your intended audience. So, everybody in the audience, thank you for joining us, and be sure to pick up a copy of Liz's book, or go ahead and get the app if you're not quite ready to run out to the bookstore, or Amazon, or wherever. All right, everybody, thanks so much.